Hello, what's up? I'm Junchan, and we are back on stream for some more Comonad related things. I was away for a week, great vacation in Paris, had amazing food, get to see my family. And yeah, I did some work while I was over there. Didn't have the right setup to stream, also thought it was a good idea to take a little break. So, but we're back now, and let's just jump into it. How about that? Oh yeah, I could actually have my camera here. Okay. So what did I do while I was away? One of the things I've been playing with is to. So I'm still interested in how to design an application using comonads and following on Phil Freeman's work on comonadic UIs, and try and see how I can use other comonadic structures on top of the UI component comonadic structures that Phil Freeman's talking about, and see how those would compose together. And one of the things that comes out of doing this type of thinking is how do you, so comonads usually will have the structure, and then their implementation will usually be an interpreter, and the application and the external event and the user events will usually create monadic actions, and then those monadic actions will somehow move inside a comonadic space, and the way that it moves will be related to the comonad's implementation, and so it could be seen as an interpreter. The interpreter of the monadic action will be the comonad implementation. The thing is, though, if we want to have this kind of comonadic interpretation, if comonads are pure, so if we only have comonads floating in the Pure Lens, we can't really have them do any side effects like calling over the network, fetching things from the file system, and so on. So the idea that is documented in various places is that it kind of means that you need to mix comonads, pure comonads, together with comonadic coeffects, what's called comonadic coeffects. And in practice, what this means is that you need some kind of way to make your comonad call IO actions, or in PureScript effects. Basically, it means how do you combine a comonadic pure value with a monadic effect structure. And you can't use comonadic transformers because comonad transformers actually stack comonads on top of each other, but you don't have a comonad that actually has side effects. Although, you know, it's not impossible to think about that if I think for a second here. So maybe I should note that as a question. So comonads, questions. In principle, do effects / coeffects really need to be interpreted or / running? Is that 3 ends? Yes. In IO / effect. I mean, in practice, sure. We want to run in effect unit or IO units or something. That's actually I'm mixing up PureScript and Haskell right there. So we want to do that, but is that really an actual PL constraint? Is it a programming language constraint here, or is it just that we use an effect? We use monads to describe effects in compiled PureScript and compiled Haskell. We use monads to describe effects in PureScript and Haskell. But the truth is, we know from the pointer from Andre Saltz that mentioned in the Cycle.js documentation that there used to be a thing in the Haskell report 1.2 or 1.1, which we looked up on stream already, which said that Haskell used to have a dialogue-based effect system. But Haskell had once in a time a dialogue. It's like stream-based I/O. Oh, hey. Fragilities, thanks so much for the follow. Really appreciate it. Welcome to the stream. I am a bit waxing lyrical here, or theoretical. I wasn't streaming for a week, and so I'm sort of trying to condense a little bit what I did. And so far, I haven't really shown code. And also, I've actually started having some new ideas on what happened last week for me. So let's get back to it. So the fact that once in a lifetime, or once in a time, Haskell didn't use monads for describing I/O effects means that the fact that it used monads now, and that PureScript used monad now, is not necessarily, like a programming language constraint that needs to be so for every programming language. I think in theory, we could have a programming language which interprets comonadic coeffects directly. And to be honest, it's possible that this is something that is pointed several times in documentation around coeffects. Comonadic coeffects by Thomas SP, context-aware programming languages, and I think this is probably what it's about. I haven't read it still, and the project's open source, but it's written using F#. Interesting. But I wonder whether that's what it's about. Whether in the end, if your main is in, let's say, coeffect unit or something, then then you obviously your compiler needs to speak that, which is not obvious, but it's kind of interesting. But I'm going to just copy that here. Is this maybe indent a bit? Is this what coeffect is about? I don't know, but the fact is, we don't have to wait to write a new programming language, thankfully. We can just use the technique that is described by Phil Freeman, again, very genius functorial, coeffects. And because I realized, and I think I've asked this question on stream before, I didn't quite know how to address it, but this blog post actually gives a solution, which is basically about interleaving monadic effect inside a comonad, inside a comonad transformer, really, but not of any shape. It's the so it's the co-constructor, and the co-constructor takes any monad and the co-constructor takes any comonad and transforms it into a monad. And we've been using that, and that's part of the thing that seduces me in here, the idea that we can write our comonads and then deduce, not have to write by hand the equivalent monad, just use the co-constructor, get our monad for free, maybe even get some monadic values for free. And in this case, by using co-t, we should be able to make it so that our comonadic interpreters in co-t can run with a base monad, which will want to be the effect monad or the IO monad in Haskell. So, so basically, I think just to wrap up this question here, I think this would mean pushing co-t into the compiler, basically. And I don't know what that means. I've never written a programming language before, but I think that would be the general idea. So, okay, that being said, let's go back to my experiment in trying to make co-t work. And so where is that? So I think I tried to make it work by first of all using our counter example, not our counter example, but our counter example. Sorry, it's there we go, co-t. So in the example, using a counter here, that is quite simple, right? It just has we define our comonadic. We describe our comonad by using a co-free base functor or pattern functor, which is here. And then from that, we define our counter space comonad, but we do something different this time. We compose the counter interpreter with effects, the effect monad. And so that's the pattern here. Here, Phil sees that the shape we want is that we want to interleave an M inside our co-free construction. And he notes that actually that's just the same as co-free compose MF. We compose M, our base monad effect, with our counter interpreter. And so that, in theory, means that now our comonad counter space should be able to run effects into the effect monad, and we'll want this to be F at some other point, and then that'd be great because we have this principled way to introduce side effects inside our comonadic interpreters, and that will allow us to define a comonad, like create a database and actually be able to send stuff over the wire to a database, which would be nice because otherwise our comonads are pure and we can just have like these kind of pure interpreters, and we're a bit stuck finding where we're going to be able to run our monads. In fact, I was even starting to think about how and I think I also streamed about that, how maybe I needed to sandwich like monads with comonads with monads with comonads. So I think with this, it is a kind of a sandwich, but maybe a principled one, at least for now, which, because I presume there's a deeper structure in there about like gluing this monad and these comonads together. Basically mixing, because nothing prevents M to be a monad transformer stack right there. So since counter space could also be a monad transformer or counter interpreter, or it could be co-free T, for instance, and then that would be a comonad transformer stack. So it means we can attach comonad transformer stacks with monad transformer stacks, and that's a bit mind-blowing. And I think that if we do that a little bit arbitrarily, probably the shape might be a bit hard to reason about, but I think there might be ways to maybe sandwich things, and then it feels perfunctory to me. I don't know why, but but it does. And so maybe at some point I'll be able to see the pattern more clearly. But until I get into this fairyland abstractions, I just want to make this one work in code with some example, because this is actually solving an actual problem for me, which is that I want to use these comonads for real. And to do that, I need my comonads to have some side effects. So can I do that? And I tried and I couldn't quite get it working. So I picked up some stuff from Phil's code. They're written for Haskell. And so here's where I got stuck here. Insufficient permissions. Okay, so let me, since I synced back from the laptop, the external hard drive I was working on, I'm going to need to get everything back to the right user. Okay, yeah, that's it. So and -R. And save. Okay, so what was I saying? No type class found. Yeah, so that's where we're stuck right now. So I was able, sorry, not about, to create those monadic values. They existed before in a slightly simpler shape with only counter interpreter in the co. But so now we're saying co and compose effect counter interpreter unit. In fact, we're trying even to say co t compose effect counter interpreter effect unit. So that's something that Phil talks about. The idea is that so co-t will take our co-free comonad here, and we'll be able to allow us to create a monadic value from the pattern functor of counter interpreter, as well as run arbitrary side effect in the effect monad that's in there. So that's a bit, I find it a bit weird that this is repeated here. It feels like maybe this should be maybe neater, like that. But I don't think we can do that. And here I actually haven't used the possibility to do effects, but I think I actually can. I actually can, and indeed I can. This is not a type error, so I can run any side effects in the effect monad now in my monadic action, and so that's even better than well, actually, okay, I was gonna say something that I don't know yet. There's a possibility that I want to keep ink pure, even if I can not do that, and then that I want the interpreter to do the effects somewhere. Here I return a pure value, so it means that in theory I should be able to interleave some effects inside the interpreter too. So that's something I'm not clear about this design yet, so I'm going to maybe write it in pair. Pairing, and some questions here. With co-t compose effect interpreter effect A, we can create a monadic value which also runs monadic side effects in effect. However, don't we rather want to keep our comonadic stack pure and have our side effects in the interpreter? So here, the interpreter is what gets fed to build co-free. So, and then build co-free, which arguably so yeah, how to say this? Now counter space has effect in it, and build co-free is now building a comonad that does have interleaved monadic effects. So then later, when we run explore, which means that at that point we are hooking up the potential monadic actions that are generated through callback, through user actions and whatnot, to our comonad, and then probably running side effects. The question is, first of all, one of the things that I did during my time away was to try and understand Explore a little bit better, especially in light of Qt, but also in light of Explore that exists, I think, in CoFree. Conquer Core, no. Okay, let's find Explorer. Yeah, it's in free, so it's in CoFree indeed. So there's an Explore in CoFree, which has this shape, which is in fact the shape of zap or pairing. So I started to go deeper into pairs and zapping, and not the whole math adjunction side of it, but trying to understand the pattern and trying to understand where React Explore comes from, and understand also how specifically PureScript React Explorer uses this side effect there to modify state and where, and the fact that it uses in Explore is actually quite interesting. But basically, the question is, where do we want our side effects to be ran, right? And so the fact that we can't put them inside the comonadic action, it could be that this is actually turns out to be the most intuitive to write. I think because in here we're going to get basically the payload from the monadic action, and it would kind of make sense to interpret it right now. On the other hand, depending on you know, like if we want to kind of mock things, if we want to do the things with effect systems and basically be able to interpret something into a mock environment where we, instead of fetching database and calling actual database, making actual database calls, we run in purely and feed constants or whatever. So here we see that pattern already is a kind of bit wonky to do that, right? So do we want to keep interpreters pure? And here also I think I'm overloading the word interpreter, because I've called my comonadic base functor for the CoFree comonad. I've called this counter interpreter because this has a kind of a interpreter shape, but really it's only implemented here. And the fact that it's implemented here, to be honest, is also strange, because this is fed to build CoFree, and build CoFree really creates a CoFree comonad, and so in theory, shouldn't we still be pure at that point? And shouldn't it be at the explore layer that we actually potentially pass either a effectful interpreter or a mock, a pure interpreter. So those are some questions that I suppose I can write here, which it's similar to this, right? To what I just said here. So how about side effects in the interpreter? But then that kind of begs, like, but where does the actual interpreter live? And is my use of the term interpreter a bit wonky here? And I think it probably is. So maybe we should try and clean that up in our terminology first, because otherwise it's going to keep confusing us. So here, this is really the base functor for the counter. Calling it interpreter is not quite right. It is the API for the interpreter though. So we could call this API. This is not a bad term. We could call this interface, counter interface. There's two ways to, yeah, I kind of like that actually. Let's call it interface, because it means only changing a predator to a face. And that's a nice minimal change, I think. Except I'm going to, oh, so that's actually counter interpreter interface. Counter interface. Okay. And that's going to mean changing it here and here. And also we need to change the, I did it already. And here as well, and here as well, and here, and here. Okay. So now our interpreter is built from an interface, which is kind of nice. So here's a question though. Do we need so there's one way where we could, for instance, still have this pure, right? But make our interpreter either called with compose effect counter interface or be called with counter interface. That's an interesting thought. But it still feels problematic. And in this case, maybe my whole COT thing is a fool's errand. Because it still feels weird to have my component carry the compose effect and the COT types. So counter space at this point, yeah, carries compose effect, right? So in theory, we could make that M an M, a type parameter, and then, but then that would still be strange here. I suppose, though, we could pass the interpreter. But that's a bit strange also, right? Because here, this is the counter interpreter. And so does this mean... So if we want to parameterize these things, then I suppose it kind of means that potentially each component, would be able to have either a pure interpretation or an effectful interpretation if we wanted to be able to run tests in a pure monadic context. But then it would mean that we would be able to set things up at the root when attaching these components to an actual React component tree. We could, when we instantiate them, selectively run them into a Effectful or pure comonad. So that's okay. It's actually interesting to think that we could maybe even swap that on the fly at runtime. I think it probably is the case, which is kind of interesting. But now I'm also thinking, usually the pattern seen elsewhere is that we change the interpreter for the whole app. And so in our case, it would mean that if we have a tree of components, we probably also need to provide a tree of interpreters. And that means that we need to have a full tree of pure interpreters or a full tree of Effectful interpreters. Which is kind of cool. We could, be smart about how to zip those data structures together. And that sounds also like maybe a comonadic shape. With just maybe annotation. It's interesting to think about the shape of that, but I think at this point maybe I'm satisfied, but it just means that explore would be the kind of generic running. That's fine. And counters would not only take an input, at this point, counters input is something that I've changed in this version of React Explorer here. I've added input so that I could run input things, which I actually don't even run right now, but yeah, have I just got, I suppose I don't even have this code anymore in here. Okay, that's a bit strange, but I was doing something a little bit like this. I was calling input. This is all my experimentation, trying to hook up a timer and trying to run side effects in my comonadic interpreters and so on, and failing. So we'll need to get back to that actually, right? So maybe here I should write that ultimately, or maybe not ultimately, it would be good to have our timer subscription work with this approach. And at this point, I don't want to think too much about that, but so here, instead of passing input to explore, I suppose we'd be passing an interpreter, a counter interpreter to counters. And it's a little bit strange. I think, in my view, explore maybe should be pair co and should pair the counter and the interpreter, and or pair pair co pairs the comonad and the monad. And I suppose there's complexity into how we deal with the sending of said monadic effects, which are dealt with by explore with the send. So I'm not sure what the right pattern is. So right now, let's write that this is the pattern we have right now. And I haven't even really completed what this means, right? What this means is that counters will in fact have several interpreters. You will have counter interpreter and you will have counter interpreter pure, which will be in the identity comonad, and that should actually just work. And here it will take a step count. Okay, so how will we pass this? This will take interpreter, counters will take the interpreter, pass it to counter, and counter will build co-free with step counter interpreter, and then we'll pass the interpreter here. So actually like so. And then then we'll be in bad shape because we won't have count except if we pass count here, which is ugly, but at this point it is what it is. And it means that it takes a counter model as well. Okay, and then we also need to pass. Yeah, well, it's what it is, but it's pretty ugly. But let's do this for now. And yeah, we will so in here we'll make it polymorphic. And I will just say monad m. Well, actually we'll say for all m. Monad m. And like so. And we'll make it just indented slightly differently. Okay, and then what? And you can't match m with effect. And why not? Oh, yeah, because this needs to be m. And then we're back to the same error, which is good. I think it means we've refactored such that we can pass the counter interpreter at this level, which is what I wanted to convince myself was possible, which should mean that we should be able to swap interpreters, which I think is good. It means we're following the same interface, but one of these guys should be able to actually maybe, you know, fire the missiles while changing the count or something. I don't know exactly yet how that's going to happen, but that's one possibility. But maybe we want to clean that up. But how? One difficulty is the send business. Because send is this kind of inversion of control way to hook into the React callback system by passing something down into the comonad that can be called by a React event or a DOM event that triggers a React event. And that would then generate a monadic action. generate a monadic action M, which would then be used to run co in PureScript React Explorer in the explore command. So this pattern is all right, but I think it obfuscates what's going on from a more monad tied to comonad standpoint. So it could be that in PureScript React Basic Explorer, when we played with, so that's not it. That's, I think it will be in, I don't think we have it actually here. So let's open it. In PureScript Comonadic to-dos and so on. Comonad UI React Basic, I think that's where. Comonad UI React Basic. Yeah, here we have a different formulation. There we go. A formulation that also, interestingly enough, right, aims to get some base monad somewhere in there, but doesn't interleave it as co-T or co-free compose M does. But it does something neatly. For instance, this is very beautiful. And it reuses for that move, which is in fact also beautifully expressed as an action that works with a comonadic pairing. So I want to actually write that down somewhere because I was looking into this and I think that's one of the things that is definitely an improvement. And so if we don't take everything that we might want to take. And let's also write what move is, and move is this. So what's neat about this, right, is that move really takes a pairing between the monad and the comonad. And here there's some clarity in the fact that the send, I mean, if you look at the lack of craft, it's quite beautiful. Explore here is compared to explore here, which is our original explore, and the fact that it's decoupled from React, by the way, is also one of the really neat aspects of it. So it's decoupled from React, but then there's also a React Explorer. There's a regular Explorer, and then there's a React Explorer. And I think that's the right approach. At least that's the way that, to me, seems to make more aesthetic sense. So that's in PureScript React Explorer. I want to have that in front of my eyes to think about what I want. And we want this too. And that's in PureScript Comonadic UI to-dos, I think. The whole thing, really. So this the React Explorer, which is similar to this, but arguably a little prettier. You know what? Let's write them in a way that makes them more comparable. There we go. So we do get state, and then we do pure of the UI Explorer instead of extract send state, but we do extract space send. State is space here. And then we do our modify write state instead of modify state of this and this. Right. So to UI Explorer we pass a, I suppose that's an interpreter. So I think, but that's an interpreter for specifically passing state through, I think. And this might still be fairly coupled to what needs to be done in React, even though it's much cleaner and very elegant. And also, I mean, we send something in the base monad here. Does this mean that there's both a base effect and an M effect? I'm not sure here, actually, because in PureScript React Explorer, we just send an M, which is, I guess, then in CoW unit. Oh, let's go check out the type of handler base M unit. That's going to be here and here and here. So handler base M unit really is base M unit to M unit unit. And calling this base is weird. And so runco, the relationship between runco and the extend constate and the right move here, all of this is part of the thing that I'd like to try and understand a little bit better here. I've started to rewrite move, and there's an alternative formulation of move already somewhere here. Let's see if it helps. Right, it just reverses M unit, and I think it also tries to use the coeffect, not this coeffect. Okay, where did the blog post go? Blog post just disappeared. Okay. Coeffects. Extensible coeffects. Here they are. Oh, so yeah, not this guy, but this guy. Pairing and move. There's a move somewhere in here. Move. Yes. Moving pair MID, and here's moving pair dollar and M identity. So does this help to understand what happens? So here it uses the pairing type class. So we get a specific way to pair, for instance, co-free monads and co-free comonads and free monads. The pairing is enough to tell us that we know how to eliminate a monadic value together with a comonadic value. But in this case, in this case, it takes a monadic value. All right. It takes a monadic value and it eliminates it with comonad, giving us back the comonad that has been moved by the monadic action. So that's all good. And I suppose in this model, then if we are to say that there should be some actual effects being ran, then maybe it kind of makes sense to say that they are in the WA, that they are in the comonad, so in CoT with its compose effect or whatever. Still not 100% sure about that. I think this write doesn't really have anything to do, despite the fact that it executes in base unit. It doesn't really have anything to do with the type of effects we want to interleave in our comonadic comonad. It has to do with how we persist in our UI framework the advancing of a state. And it happens that in React it's really important because it retriggers a render and it reruns therefore the render function, and therefore the Explore actually also installs basically a hook into any possible DOM event that will be executed, which is the send, the send function here, which is perfunctorial in my view, and not very visibly so. The fact that it's like inversion of control, double inversion of control, and pass through the comonad, all of this makes things a bit obscure. So maybe I should write something about that. Boom. Not pairing. The double inversion of control, install hook through send and extract space send, then pass send through the comonad through the comonadic component, then using it in React DOM callback, then an event, and then so that's on the install side. And then on the use side, it's like an event calls send, advances, maybe yeah, runs or yeah, uses the modify state side effect, which re-renders and reinstalls the hook. Well, calling it a hook is wrong. It should be just a callback. It's really just a callback. Callback. And by the way that this works is, interestingly enough, is the fact that space really is a comonad of handlers, meaning a comonad of things that wait to receive their value. So when we call it with send, we are really creating a comonad of continuations, actually, that just waiting for their value. And then when the callback calls the value, then poof, the comonad gets a value. So from a W of A to B, provided with an A, then we get a WB, I think, or maybe just a B. So the to-do is not this, I suppose. The to-do is, can we rewrite the double inversion of this double inversion of control as a profunctor? How about that? Why do I think that's something like a profunctor or an arrow? Is because this really feels like we're just installing some input, which are going to be the React DOM events, and we're saying how we want to connect those to state advancing, or yeah, we want to say, oh, the result of actually calling this event is going to be this business logic, which is going to be the code that is so far inside inside this send, the wrap free move right here. This thing is the monadic action, so that's the business logic. That's really, we're saying this React DOM event triggers this monadic value, and then we know how to, then with an interpreter in the mix, we know how to do something smart, applying that monadic value to our comonadic space with our interpreter. And then at the end of the arrow or the profunctor, we're persisting state, which is also happens to then later, maybe in the framework, retrigger a re-render. And then that re-render, it happens, actually makes sure that any future event will also go through that same processing pipeline. So that's how I'm seeing that this is actually better visualized, in fact, as a kind of an FRP-ish, arrow-ish, stream-ish connected driver, which is back to Cycle.js and the way that this is hooked. So I wonder whether actually maybe is Cycle.js going to be useful there? It might be, you know what? Look at Psycho.js, but I don't know whether I'm going to. I mean, at some point, I suppose I will pop back the stack and be able to go back to something like that. But right now, I kind of need to continue a little bit dwelling in the shadows or in the depth. So where were we with our example? This. Here we have something a little bit ugly, and we don't know also how to make the type align because we don't know yet how to pair our Coty thing. In fact, what this really says is that we don't have a monad free instance on Coty. But that might not be so horrible to try and write, in fact. But is this what we want? I think it's close to what we want. It's close to what we want. I think need to convince myself that I can write this in a style that allows me to interleave a monadic action somewhere. But I think that's not too hard, right? Because I just need to say do here. And then I think I can do something like log show count. I think I should be able to do this, right? Yeah. Effect. Yeah, I think it's possible to do that, and obviously just to convince ourselves that we're sane. If we say this, then this shouldn't type check, but it does. So we might not be checking the right thing. So class instance. Okay, maybe I need to restart script ID, and maybe I need to also check whether I can Spago build. So it could be that the fact that this doesn't type check actually prevents this to type check. Yeah, because this shouldn't type check, right? Here log is in the effect monad. How would I be able to run something in the effect monad when I only have the identity monad available to me? So I suppose that we're just at a different phase of our type checking and blocked here before PureScript can actually interpret this type error. So what time is it, by the way? 9:12. Okay, I'll stream a little bit more. Okay, so maybe I need to look at how Arthur Xavier does this, because I remember he did this in a much prettier way. And yeah, he was able to just do void by doing what? I don't know, he had to wrap free too. Yeah. Is that, maybe that's not the right one. Comonadic UI, blah. Yeah, no, he did have to wrap free as well. Yeah. Did have to wrap free. So let's remind ourselves what wrap free is, and let's go back to our actual example. And wrap free, could you take me to wrap free, please? wrap free is just this. So FMA to MA, when we know that we have we know that the functor F is the base functor of the monad M. So then it just unwraps the M. But unwrapping the M, right, in our case, since we're using co's, when we ink, we're trying to get the free monad wrap free instance. So I think that makes sense. So in theory, we would want monad free co-t, right? That's the that's the one that we can't we couldn't write. And I think that what happened basically last week is that trying to write this, I just realized that that this was too difficult to solve at this level, that I had too many questions. So it could be that now is the time to go back and to try and solve it at this level. But at the time, I was like, you know, still not versed enough in understanding the different moving parts. And so I started to rework the pairing library. And that is here. And I updated it, and I started to see whether also I could do some stuff that came from Edward Kmet's work on the bifunctor instances, not just the regular functor instances. So I started writing tests for it, and including for the bifunctor instances, like which one was it? This guy, using exactly the same example from Ed in a blog post from 2008. This here, the bidual, I called this by pairing, and have the bizap thingy, this double arrow apply kind of thingy, and the two instances, one for tuple either and the other for either tuple, led me to also actually ask myself some questions about the ability to do symmetric type classes, and actually did an instance chain there to try and provide symmetry. And I don't know, that might make compilation super slow, or it potentially also make the runtime crazy at each call. I don't know what the implications of this crazy chain of else instead of, but that allows to basically have all of the reverse pairings immediately or automatically available. I suppose I could do the same thing here, except that right now I still haven't transformed this into a class. So next I would need to, for instance, have I could start that by pairing folder with a class file. Where did the by pairing folder go? Oh, I probably don't have the rights. Okay, so let's chown in library pure script pairing, and there we go. We retry and it works, and we paste class in it, and we call this by pairing, and then we can do also a class which will have a pair that will be a little bit more crazy. Boom. And that would be by pair, I suppose. And then we'll have by zap. and by zap is pairing identity. Is that gonna work? Probably is not. Zap in co is pairing blah, and by zap, yeah. Also, no, they must just be by zap pair identity then. With being provided a pair, I think. No, maybe not. No, not being provided a pair, being provided the pairing. So I don't need to, I just need to have a by pairing. And then I think I need a PV. What is the type of by zap? This. Okay, let's see if we can reconnect the ID. No. And that might be because I need to npm install things in here, because this I think is using PureScript 14. It is PureScript 14.3. So let's go and install this, because I started to also try and have at least a couple of libraries that are upgraded. So we are going to remove node modules. They're not here. So npm install. And here we should have PureScript 14. Well, yeah, 3 is fine. Forgot why. I think I was troubleshooting. It's going to work. PureScript PSA needs to be big. But this is not working. Allow different because it's not compiled for our. So let's just try with 14.2, hoping it will not break, and that actually there's a binary for us here. There is a binary for us. There is not. But what's the deal there? Ino and is the same thing that happened there? Yeah, it did find a binary, but it just doesn't work correctly because spawning gives Ino and that, but why? I think at this point, why would it be in this repo? It doesn't make sense. Which version of npm am I using here? 14. That sounds very recent. I think I want to go back to new 14, but I think I'm going to have to see what this spawn end thing is. Let's try. Too bad that we have to do system things. PureScript deprecated, spawn, FreeBSD. Yeah, that sounds. npm install PureScript. Sudo. You're saying you can't. I mean, what's inoent? Command does not exist because working directory does not exist. Yeah, that sounds right. I don't see how there would be a node module PureScript bin at this point, because this should be in a different folder. This is trying to do this as a post install. So let's see what's in there. Well, we don't have anything in there. It didn't even succeed to install it. That's annoying. That's very annoying. Also don't remember, could it be, I mean, clearly this is going a little bit against the grain of NixOS, but let's make a better search. What was this? Starting PureScript. That's what gulp PureScript. I don't think. Is that PM minus G's? That's the one we saw. PureScript Nix example. Yeah, but I don't want to have an Nix shell in here. But is that going to be needed? It's possible. It's possible I'm going to need a DRAM and a local flake, something like that. That's not good. Okay. Apparently I'm not able to type anymore in my terminal. .lsp. What's going on here? Okay. Clear. Doesn't work. Oh, works now. Okay. Strange. Should I try and sudo npm install? It's a bit ridiculous, but access permission denied. What? So that's the system-wide. Oh. Very unsatisfying. Require resolve burst bin, which isn't here. Permission denied in root.cache. Okay, fine. npm install. Yes, terrible. So I suppose I could Nix shell -p PureScript. But that's only 0.13.8. Yeah. So I need to update my channels and whatnot. Why is this path wrong? Downloading here. Maybe I npmi with verbosity. What's the thingy? Install help. And okay. Okay. Verbose. Okay, he says okay, but I think that's wrong. Okay, so it downloads, but it doesn't succeed in saving the download binary to the npm cache directory. So okay, where is the npm cache directory? Okay, I'm getting the same error. I'm fine. npm help. npm is there something for the config list? To show all defaults. Home.npm. Do I have a space problem? No. 83. Yeah, that's 71 gigs available. Yeah, that's not a problem. Or is there something going on with how the path is fetched, which okay, we're going to need to go a bit deeper into this rabbit hole, I'm afraid. GraalJS, npm use cache. I mean, the first hit is pretty spot on. It is in PureScript, but yeah, it is in install PureScript. That's correct. So maybe we just do GitHub install PureScript. npm installer. Install PureScript. Save. Okay. So whatever it is, it's happening elsewhere. Save the downloaded binary, blah. Save the downloaded binary to the npm cache, write cache, the downloaded allow failure true. It's a task group. Write cache complete. write cache fires when it starts to create a cache. Fires when it fails to create a cache. This is very involved. This is very involved. Is that a state machine? Write cache. What's the dealio with write cache? Download or build. Let's search for write cache again. Observer next ID write cache. Try cache cleaning bin stats permissive bin path cache stream CAK cache put stream cache with your cache key permissive pump. Oh, it's using this the lightweight stream thing is, I think, from Dominic Tarr, is that? npm pump. Pipe stream together. Macintosh. Macintosh from Hypercore, which we're using in our other streams. Okay, this is a big rabbit hole. I am going to take a little break and decide whether I carry on or if I pause and resume next with more of the rabbit hole-y kind of things. I'll be right back. Hey, let's just do a little bit more, even though this is really just about installing pure script, and we'll probably just stop there. You know, I'm a little bit obsessive, right? It's good to try and finish those things. Okay. So what's up with this cache thing? Cache key is install pure script binary. So apparently there's a whole thing with a cache key, and somehow we require CA cache. What is that? What is CA cache? npm CA cache. Managing local key and content address caches. Even the cache file. Okay, that's okay, but where cache path needs to be a thing. Okay, so you are supposed to have a path, and the question is, where is there's a bin path. Where is the cache path? Error.path, cache path, info.path, and then as a search cache as well. That sounds very involved. But I think here we're reading from cache and writing to bin, and that's in search cache value. That's in not sure when this happens. It's not in main. It's in observable. I don't think it's in main. No, it's after main. So it's just is it just an immediately executed? It is an immediately executed function. So that thing is part of some kind of main. Very hard to understand control flow. Restore cache. Let's look at the diagram again. Searches cache first, and then if it finds it, then it restores it and checks the binary, and then it I see, yes. But the problem is that, so what I see is that this is meant to be allowing to have a central non-npm, maybe presumably, place to put binaries, so that even if you install it from different machine, or not different machine, but maybe even different users, maybe, or at least different repos or different folders. And if the npm cache is not working for that, which probably doesn't, because it doesn't have, it wouldn't have a binary cache, then this is a binary cache for it, I suppose. So, but the problem is that it probably needs some kind of permissions in order to. It needs a cache pass. That's the thing. So when we do, if there is a CA cache, well, there isn't a CA cache put because it uses a stream-based interface for cache for copying things in and out, but it so this is just trying to restore, but hold on, this cache path here, that has to be the complete path, not the root path, not that cache path here, but the complete path, including a key and maybe even some whatever that is. So I think that's the restore attempt on first thing. But then if we fail to restore, then that's probably where we get into the download, and then we get into the write cache. And so first of all, apparently we try to cache clean. And presumably, so it could be that it's failing right there. Cache root there, that's what we're looking for. It could be an option, and there's a default. And the default is purescript npm installer.cache in env path. Oh boy. Okay, what's that path? Path env blah. Use the correct OS specific path. Pass my app dot local share my app. Yeah, most developers get this wrong. Fantastic. It doesn't it doesn't work for NixOS, does it? local share. So maybe if I create a local share in my home, it will work. Do I have a? That's too much info. Local share. There's no pure script in there. And I mean, this is writable with my user. Oh, .cache, is that right? That must be right. That's I think is where he was getting. .cache. So env blah .cache. So which is that going to be? In Linux, it's going to be .cache and then blah 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 Node.js. There we go. We have it here. Script blah 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 and nothing in it. Okay. So we found where our thing is. So that's good, I suppose. We know we use the cache root here. We clean the cache. That we try to read where the bin path is, right? And the bin path is where, by the way? Yeah, it's wherever we download, and it says we downloaded correctly, but it's not clear where we've downloaded it. So do I have to check where? I suppose I have to check where download happens. Download or build. And download or build version. Then maybe calls download. Is that what's happening? Download pure script. Yes. So let's go check out download pure script. And that downloads pure script where? Searches for the thing. Return DL tar. Oh, DL tar. It takes a URL and assume a destination folder, and then outputs things. Well, if we console log things. So it could be that it doesn't download. It is short. What do we call it with? So that's the env path, and we call download of pure script. Subscriptions, add TMP subscription, default version, options, I do not like this code, I gotta say. Okay, that doesn't mean that I need to do something stupid like that, but and then also options are gotten from args. And so I suppose download or build PureScript will get a destination. Options. Yeah, events are fine, but options are here directly passed to those. And additionally, we can do rename. Okay, so I suppose it's download PureScript is not here. Download PureScript. Options. Strip options. Follow redirect. Version. So you're calling dltar with which destination process.cwd. So you're trying to download in the local folder? That's strange. I don't think that's true. It might be happening in here. Link bins, press.bin, but we know that's not going to happen at this point. You'd think this would give some logging messages, but it does not. Wouldn't it make sense for downloading library to say where it downloaded the things? I really think it should. Filter base URL. Yeah, now I'm just going around in circles. .default version, bin name, bin path, join CWD and bin name. So that's supposedly where we download in the current directory. And the current directory seems like it's where, I mean, it depends what npm install does, right? Especially a post install hook. It could be running this from here. At this point, it doesn't exist. It could be running from a temp directory, wherever. It could be running here in the node process folder. Yeah, all kinds of CWD is supposed to be PureScript actually. Yeah, in the post install. So this might not even exist at that moment. Maybe because of this kind of circular problem there. It could be that it could be in that case that is an npm error. If I next shell npm. That's not a thing, right? That might be a thing, but I doubt I have a different version here. Yeah. Which kind of makes sense, but is also annoying. Okay. So I could also just try and install pscript-leo 14.3 globally. This is really annoying. This is really annoying. Yeah, let's do which purse. The next door. And default with all of the recent things. Okay, well, I suppose I could do that. Although usually you want a shell, right? But add that shell, import the. Okay, fine. Let's do this the next way. Is there a flake? Maybe a flake. There's no flake. It's fine. There's a pinned thing. That sounds dangerous. Oh, it's in pinned. Okay. Yeah, I don't like that, but for now, let's just try and get out of our predicament. And so you're saying we do not nixshell ci nix, we do so hold on, isn't that? Oh, I see. So that would be another way to make this work. Okay, but I think we just want to do nixshell here now. And easy dial. Okay, apparently there's lots of dependencies here. I don't know. I definitely dislike all this. But at least it exists. And that didn't work. PSA import. Ah, right. Okay. Yeah, it's trying to import all the things. So hold on, maybe I'm using this wrong. I should just have this, and I should just build input. I think that's what I'm doing wrong. I'm complaining when I'm not using it wrong. I'm not using it right. shell, boom, zpers 14.3, and Spago, I suppose, 0.20. Just Spago them, and shell. Yeah, that's better. Is that the right revision though? Might not be. Yeah, exactly. 14.3 is missing. So I need to point to another revision and therefore another SHA. So let's take a look at the commits and copy that, and what's the SHA? Really? That doesn't sound good. Why aren't you rebuilding a thing? Okay, maybe that's going to be better. Yes, good. I think yeah, I don't know. All of a sudden I have a doubt. No, it's fine. Hey. Whew, we did a thing. And then Spago should also be 0.20 or something. It is. So what? So we don't npm install because we have the things. And therefore we Spago build. And we actually run, I think, our code from there. Right. Since we started to do a type class based version of bipairing, clearly we have tons of stuff that should be bipairing, and we have an IDE as well. So that's good. That's 2 hours. We at least get back to be set up and think about things. Still a lot to think about. I'm not sure about which way I'm going to go to actually make progress. We have a lot of questions. It feels like I have a little bit of everything still laid out all around my desk with tons of options, and I'm still kind of staring at it, trying to make sense of it. But ultimately, it's still progress, and in any case, it's also very much learning, and so that's good. That's why we're here. And so I'll see you on Thursday in 2 days for more adventures in Comonads and trying to get our Comonads to do some neat effects, tricks as we want them, and hopefully make all this composable and nice for us. So that's it for today. Thanks a lot, and bye-bye.